my name is Mmesoma Chukwunwike. I am a student of Fountain School. I am in SS1. Today's lesson is about a topic everybody is familiar with, which is indices. So I'm going to start by giving a history of indices. Indices simply means powers. Before it was called indices, it was called exponents, which comes from the Latin word expo, meaning out of, and ponere, meaning place. It was first used in a book which is called Arithmetica Integra, which was written by Michael Stiefel, an English author and a mathematician, in the year 1544. Indices can simply be defined as expressing large numbers, because during those times in Babylon, it was difficult to express large numbers. For example, if you want to say 10,000, instead of writing the 10,000, you can write 10 raised to the power of 4, which simply means 10 times 10 times 10 times 10. So now if we say 2 raised to the power of 5, it simply means 2 times 2 times 2 times 2 times 10. That's 2 raised to the power of 5. So now we're going to go into the laws of indices. Law 1 is called the multiplicative law. This law states that if A is raised to the power of m times A raised to the power of m, since the bases are the same, you pick one of them, which is A. Then this multiplication sign turns to an addition sign, which is A raised to the power of m plus n. For example, if we have 2 raised to the power of 2 times 2 raised to the power of 3, this simply means you pick one of the bases, 2 raised to the power of 3, 2 plus 3, which is equals to 2 raised to the power of 5. Law 2, the divisive law. This law states that if A is raised to the power of m divided by A raised to the power of m, since the bases are the same, you pick one of them, A, and this division sign turns to a subtraction sign, which means A raised to the power of m minus n. For example, if you have 2 raised to the power of 2 divided by 2 raised to the power of 1, this simply means 2 raised by 2 minus 1, which is equal to 2 raised to the power of 1. Law 3. This law is the zero law. This law states that anything raised to the power of 0 equals 1. If 20 is raised to the power of 0, it equals 1. So someone may ask, can this law be proven? And I'll say yes, because we can prove this law with this example. If 2 raised to the power of 4 is divided by 2 raised to the power of 4, we all know that it simply means 2 raised to the power of 4 minus 4, which is equal to 2 raised to the power of 0. Now, we're going to split 2 raised to the power of 4 divided by 2 raised to the power of 4 in another way, by 2 raised to the power of 4 divided by 2 raised to the power of 4, which is equal to 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. Now, this 2 here comes here is 1, here is 1, cancel out 1, cancel out 1. So we have 1 over 1, which is equals to 1. So now we come back here, we see that here is 2 raised to the power of 0. And because these two things are the same, we see that 2 raised to the power of 0 is equals to 1. The next law, law 4, is the negative index law. This law states that if A is raised to the power of minus m, it will become 1 over A. This minus change to 1 over A raised to the power of m. For example, if we have 2 raised to the power of minus 2, it becomes 1 over 2 raised to the power of 2, which is equals to 1 over 4. Law 5. This is the bracket law. It states that if A raised to the power of m is in the bracket and n is outside, it's equals to A raised to the power of m times n. So for example, if we have 2 raised to the power of 2, raised to the power of 2 is equals to 2 raised to the power of 2 times 2, which is equals to 2 raised to the power of 4. And this is the last law, which is law 6, the fractional or root law. This law states that if a is raised to the power of, this law states that if a is raised to the power of m over n, it means the m roots of a all raised to the power of m. For example, if we have 2 raised 8 raised to the power of 1 over 3, this means the cube root of 8 all raised to the power of 1, which is equal to, the cube root of 8 is 2 raised to the power of 1, which is 2. So now that we're finished with the laws of indices, we're going to apply this law and solve some questions on it. So this question I want to solve is from JIKWOYI. It's from JIKWOYI. It's 64 raised to the power of 1 over 2 plus 125 raised to the power of 1 over 3, all raised to the power of 2. Now this will apply the fractional law, which when I say the square root of 64 all raised to the power of 1 plus the square root of the cube root of 125 all raised to the power of 1 in square root of 2. Now the square root of 64 is 8, and the cube root of 125 is 5 raised to the power of 2. Now 8 plus 5 is 13, so now we have 13 raised to the power of 2, which is equals to 169. So now I'm going to solve another example, but I want to use this example to tell us something. While I was studying this laws of these indices, even when our teacher taught us, I discovered something and I would like to let other people know it too. I found out that if we have some 125 raised to the power of minus 1 over 3. Now we are going to apply 2 laws here, which is the root fractional or root law and the negative index law. When I started solving this, I applied the fractional law before the index law, which makes it difficult to solve. But if you want to make it very easy, you have to apply this. You have to remove this minus by applying the negative index law, which is 1 over 125 raised to the power of 1 over 3, which is equal, then you raised to the power of 1 over 3. Now you say 1, because of, you say 1 divided by 25, 125 over 1, change to 1 times 125 over 1, which is equal to 125 raised to the power of 1 over 3. Now we find the cube root of 125. Find the cube root of 125, which is equal to 5. Going to indices in quadratic form, but before we start, let's solve normal quadratic form. For example, x squared plus 8x plus 15. Now we join 15. We multiply 15 to the coefficient of x. That's 15x squared. So now we'll find 2 numbers, and when we add them together, it will give us 8. And when we multiply them together, it will give us 15. And those 2 numbers are 5. So now, we're going to, since we have found these 2 numbers, we're going to replace them. We're going to put them in place of this x. Right? X squared. Instead of writing 8x here, plus 3x plus 5x. Because when you add these 2 together, they still give you 8x plus 15. So now that when we are at this step, we now put them in brackets and leave a sign in the middle. Like this. So now when we have done, now that we have done it, we'll find the factor that is here. The factor you can see. Factor that you can see here, and you can also see here, which is x, because you can see x here, you can also see x here, so you put x. So now you say x into x squared, which will give you x, plus x into 3, which will give you 3. Plus, don't forget to put this addition sign in the middle. Now you find the factor, you can see here, that you can see, which is 5. Because 5 is a factor of 15. So you write your 5 outside and you open the bracket. 5 into 5x is x. And 5 into 15 is 3. So now we can see that we have the same values in each of these brackets. So now we join these ones together. We should now put them in brackets. Have x plus 5. Then you pick one of these because they are the same. X plus 3. So now let's go into the part of indices. We have 5 raised to the power of 2x minus 26. Open the bracket. 5 raised to the power of x plus 25 equals 0. So now we start like this. Since these two, we know that these two from the law of indices, we know that these two are joined. These 2 and x are joined together because of the bracket law. So now I want to separate them. So we have 5 with x, then the 2 will now be in the brackets, minus 26. Your 5x will still be in the brackets, plus 25 equals 0. So now we need, for all this, to make this easier for us, we need to give a value, assign a value to this 5x. So let's assign y. 5x. 5 raised to the power of x equals y. This means that anywhere you see 5 raised to the power of x, you put y. So now we are seeing 5x here. So instead of putting 5x, we put y. We say y raised to the power of 2. Now we are seeing minus 26 times, since this 5 raised to the power of x is y, we say minus 26 times y, which will give you minus 26y plus 25 equals 0. So now we're going to look for two numbers, and when you add them together, they'll give you minus 26. When you multiply them together, they'll give you 25. So those two numbers are minus 25 and minus 1. So now we're going to this minus 25 and minus 1, we're going to put them in place of this minus 26. So now if you say y squared minus 25y minus, instead of putting minus 1y, since 1 is already the coefficient of y, we just put minus y plus 25 equals 0. Minus 25y. So now we're going to put them in bracket and need a sign in the middle, so we put them in bracket. So now we're going to look for a factor that is here and it's also here, which is y. So y divided into y squared will give you y, minus y into 25y will give you 25. Close the bracket to put a minus c. So now we have to check again. Before you open your bracket, you check what factor is here that is also here, which is 1. You put your 1 outside, you open your bracket to y. But because this is the multiplication sign, you have to first say that which, if you say minus times plus, will it give you minus? Because these two brackets must be the same. So instead of putting plus here, you put minus, because minus times minus, because you say minus times minus to give you plus. You have to, if you put minus times plus, it will not give you this plus, to give you minus. So you have to do minus times minus to give you plus. So you put your minus here. Then 1 into 20 to give you 25. You close your bracket, which is equals to 0. So now since now the two of them are the same, we bring these ones together. You have y minus 1, close your bracket. Then because they're the same, you just pick 1, y minus 25. Close your bracket. So now because we are not yet true, because we need to find the values of y, and y will have two values. So now we say y minus 1 equals 0. So now y is equals to minus 1 will jump over the equality sign to now make y equals 0. Or y can also be y minus 25 equals 0. So when you y will not be equals to minus 25 jumps over the equality sign equals 25. So y can either be 0